Hello everyone, this is the last video of our first chapter in chemistry. Today we are going to study about percentage composition. Sometimes we want to know how much chemical or what part of chemical is present in a given medicine or any other thing. So in order to calculate how much of each element is present in a given compound or a given medicine, we can use the help of certain formulas to find out how much of an element is present in a compound. So first method is percentage composition. So percentage composition gives us an idea about the weight or the mass of an element that is present in a compound. What is the mass? It may be in grams mainly. How much grams of a particular element is present in the whole compound. Like that, we can easily calculate that with the help of a formula. So let us explain it with the help of an example. All of us know the formula of water is H2O, isn't it? And H2O is a molecule. It is a water molecule. In water molecule, we have one or two atoms of hydrogen and one atom of oxygen. Two atoms of hydrogen and one atom of oxygen. One atom of oxygen, isn't it? And we also know that the atomic mass of hydrogen is 1 and there are two atoms of oxygen, so atomic mass of 2 hydrogen is 2 and atomic mass of oxygen is 16 and we have only one atom of oxygen, so 16 into 1 is 16. So what is the total or relative molecular mass of water? Total mass of water, it is 16 plus 2 is equal to 18. So total mass of water molecule is 18 gram. So what is the formula to calculate percentage of an element? Total weight of the element in one molecule divided by gram molecular weight of the compound, that is the total mass of the compound, into 100. For example, here we are asked to calculate the percentage of hydrogen in water, isn't it? And we have calculated the gram molecular mass or the gram molecular weight of water, which is equal to 18 gram. We know that in water we have two atoms of hydrogen. We are asked to find out the percentage of hydrogen in water. So two atoms, it means we have 2 grams of hydrogen. We have already find it out here, 2 grams of hydrogen and 1 gram of oxygen. So total weight of the element we want is hydrogen. So what is the total weight? 2 grams. And what is the total mass of the compound? Is 18. Water molecule is 18 gram. So total weight of the element of hydrogen divided by the molecular mass or the gram molecular mass of water into 100. Okay, so 2 will go in 18 9 times. So 1 by 9 into 100 will give us 100 by 9, and if you divide 100 by 9 we will get approximately 11.1 percentage. So the percentage composition of hydrogen in water is 11.1 percentage and rest 98.1%, 98.9% we have oxygen. So this is how we can calculate the percentage of any element given in a compound. Hope it is clear. Now let us do another example which is given on the side. We have to find out the percentage composition of various elements of what is the element given, compound given sodium carbonate. So sodium carbonate is a compound formed of 2 sodium atom, 1 carbon atom and 3 oxygen atom, isn't it? And they have given the relative atomic masses of each of the elements. We have to find out the what is the relative mass of the whole compound, relative molecular mass of the whole compound. How we can find out? Sodium, what is the atomic mass of sodium? This is 23. How many atoms of sodium are there? 2 atoms. So sodium we have 23 into 2. 23 into 2 is 46. Then 1 atom of carbon. We know that the atomic mass of carbon is 12. We have 1 carbon atom. So 1 into 12 is 12. Oxygen, we know that the atomic mass of oxygen is 16. We have 3 oxygen atoms. So 16 into 3 will give you 48. The total of all these will give you the molecular mass of sodium carbonate. So 16, 5, 6 plus 4, 10, 106. So what is the gram molecular mass or relative molecular mass of sodium carbonate is equal to 106 gram. So we have got the gram molecular weight or the denominator of our formula, which is 106. First of all, we will calculate the percentage of sodium. We will calculate the percentage of sodium in sodium carbonate. So how much or what is the weight of total weight of sodium? 23 into 2, 46 grams, isn't it? So 46 grams divided by what is the total mass? 106 into 100. 46 by 106 into 100 will give you the percentage of sodium. When we calculate it, the approximate value that we will be getting, if we divide 46 by 106 into 100, is 43.4 gram. Approximately we will get 43.4 gram of sodium. Okay, 43.4 gram of sodium. Next we want to find out what is the percentage composition of carbon. We know that only one carbon atom is there and atomic mass of carbon is 12. If we divide 12 by 106 and multiply it by 100, approximately we will get the answer as 11.3 gram. 11.3 gram. And lastly, percentage composition of oxygen. We know that 3 atoms of oxygen are there. So 16 into 3 will give us 48. So 48 divided by 106 into 100 will give you the approximate value of percentage composition of oxygen. If you divide that, we will get the answer as 45.3. 45.3 gram. So this is how you find out the percentage composition of the elements in a compound. Hope it is clear to you how we do it, isn't it? Okay, now another example. Find the percentage mass of water in washing soda. Washing soda is sodium carbonate 10H2O. 10H2O is known as the water of crystallization. What is it? You will study later. The sodium carbonate, we have already seen that the relative atomic mass or the molecular mass of sodium carbonate is 106. Now we have to find out the relative molecular mass of water, 10H2O. 1 molecule of water equals to 18 gram, isn't it? So how many are there? 10 water molecules are there. So 18 into 10 will give you 180. So what is the relative molecular mass of sodium carbonate 10H2O? 106 plus 180, which is equal to 286 gram. So this is the relative molecular mass of sodium carbonate 10H2O, or it is washing soda crystals. Now we have to find out what is the percentage mass of water in washing soda. Percentage of water, isn't it? So we have to find out using the formula what is the weight of or the mass of element that we have to find out. 180, isn't it? 180 by, we have to find out the percentage composition of water, isn't it? So 180 is the atomic mass of water. How many atoms of water are, molecules of water are there? 10 molecules. So 18 into 10, 180. And what is the total molecular mass? 286 into 100. So if you solve this, you will get 62.9 grams. So in washing soda, what the percentage composition of water is approximately 62.9 gram. Hope it is clear to you. Now the last part of this chapter is empirical formula. What is empirical formula? It helps us to find out the ratio, not the mass. It helps us to find out the ratio of each element in a compound, or how they are existing, in what ratio they are existing in a compound. For example, let us take the example of hydrogen peroxide, H2O2. Now we have studied that during our previous classes of how to write the valencies. If there is a common factor here and here, we divide it and make it in the simple ratio. So what will we get? We have 2 by 2 is 1 and O is 1. So what is the ratio of hydrogen to oxygen? 1 is to 1. So this is how we write the empirical formula. It tells us in what ratio the elements are present in a compound. Let us see another example of glucose, C6H12O6. Here you can clearly see that 6 is a common factor in all these, isn't it? So what we do, we will divide each of them by the common factor, and let us see what is the ratio. 6 by 6 is 1, 12 by 6 is 2, and 6 by 6 is again 1. So what is the ratio of carbon, hydrogen, oxygen? They are in the ratio 1 is to 2 is to 1, isn't it? So what is empirical formula? Empirical formula of a compound is defined as the formula that shows the ratio of elements present in the compound. So they show us in what ratio these elements are present in the compound, but they are not showing us the actual number of atoms found in the molecules. These are not the actual numbers, but these are the ratio of the elements in the compound. They will not show, empirical formula will not show the actual number of atoms, but they give us an idea of the ratio in which these elements are present in the compound. With this, we complete our chapter. Hope you have understood this. If you like my class, please share, like and subscribe to my channel. Thank you all of you.